What is up, guys? The Power of Pi here, and today we're going to be looking at the 2022 AMC 12B problem quant. So, Kayla rolls 4 fair 6-sided dice. What is the probability that at least one of the numbers Kayla rolls is greater than 4, and at least 2 of the numbers she rolls are greater than 2? So, when attempting this problem, I actually want to think of finding the complement, since at least is actually a pretty common keyword that we should be counting the complement. So we want to count the probability that this is not the case. And for that, we're actually going to be using the help of a rule called De Morgan's rule. So that states that not A and B is equal to not A or not B. So we're going to actually be using this extensively in the problem. Namely, we can see that the complement is the probability that, well, at least one of the numbers Kayla rolls is greater than 4. So the not of that event would be no dice are 4, are greater than or equal to 4, or no dice are greater than 4, I should say. Or at least 2, and then it says at least 2 of the numbers she rolls are greater than 2. The not of that event would be 1 dice rolled greater than 2, or or 2 dice rolled greater than 2. Okay, so or I mean, sorry, 0 dice rolled greater than 2 or 1 dice rolled greater than 2. So this is actually like basically the hard part of the problem, and then now it's just kind of like plugging it in. So now we just need to compute this probability and then do 1 minus that. So probability. So for this, since we have OR, we want to think of using principle of inclusion and exclusion. So the fact that probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. So how can we employ this? Let's see. So let's count the number of ways, and then we'll just divide by 4 to the power of 6 at the end, since we have 4 dice and 6 options for each die. So no dice are greater than 4. So, well, each dice can take on number 1, 2, 3, or 4. So there's 4 options for each dice, and we have 4 dice. So that takes care of the first part. Now let's take care of the second part, where 0 dice are greater than 2. That means all dice are either 1 or 2. So there's 2 to the 4 options there. And then we can also have that 1 dice rolled is greater than 2. So 0 or 1 dice rolled is greater than 2. Or we could have that 1 dice rolled is greater than 2. And in that case, we choose which dice in 4 ways. And then to make it greater than 2, it can be 3, 4, 5, or 6. That's 4 ways. And then for the remaining 3 dice, we know they have to be 1 or 2. So 2 cubed. So that's the second part. And then now all we need to do is calculate the AND part. So number of ways that no dice are greater than 4 and 0 dice rolled are greater than 2, or 1 dice rolled is greater than 2. So phoning in on the 0 dice rolled greater than 2, well, then again, we can either have each dice 1 or 2, and that satisfied this first condition. So there's 2 to the 4 ways to do that. And then also, we need to have 1 dice rolled greater than 2, but we also can't have any dice greater than 4. So we have 4 choices to choose that 1 dice greater than 2. And then that 1 dice greater than 2 can either be 3 or 4, since we know it can't be greater than 4 because it violates this first condition over here. So we have 2 choices for what that dice can have. And then for the remaining 3 dice, we know that they either have to be 1 or 2. So this is the number of ways to not have what we desire. So we see that everything's actually in terms of 2's. So let's just express everything as powers of 2's. So this is 2 squared to the power 4, that's 2 to the 8th. And then this is 2 to the 4th. And then this is 2 squared, 2 squared, 2 to the 4th, 2 to the 7th. And then this is 2 minus 2 to the fourth. And then this is 2 squared, 2 cubed minus 2 to the sixth. And then this is ultimately going to be over, as we said, 6 to the power of 4. And then we want to be able to take 1 minus this. So we seek to find 1 minus, this cancels. So 2 to the 8th plus 2 to the 7 minus 2 to the 6 over 6 to the 4th, which is 3 to the 4th times 2 to the 4th. So we seek to find 1 minus 2 to the 4th over 3 to the 4th is 16 over 81. 2 to the 7th over 3 to the 4th times 2 to the 4th is 8 over 81. And then 2 to 6 over 3 to 4 times 2 to the 4th is 4 over 81. This is equal to 1 minus 20 over 81, which is 61 over 81. And going back, we see that's option D. So hope you guys enjoyed this nice, it's kind of tricky for its placement, in my opinion, probability question. Make sure to subscribe and stay on the lookout for new videos.